All right, guys, so since you didn't really have a notes video for doing word problems or modeling trig functions, I am going to, like I told you guys in class, work through the back of your homework because it seems to be where people had the most issues. All right, so I'm going to start with that third section. So it says researchers find a creature from an alien planet. Its body temperature varies sinusoidally with time. All right, 35 minutes after they start timing, the body temperature reaches a high of 120 degrees Fahrenheit. 20 minutes after that, it reaches its next low of 104 degrees Fahrenheit. All right, so the goal when we're doing problems like these, when we're trying to take a word problem and then graph it and create an equation, is to pull out all of the information that is given. All right, so we are, for this problem, looking at temperature as a result of time, right? So first I'm going to start by sketching my graph of my function. And it doesn't need to be the most beautiful graph. All right, oops, I'm actually going to make it a little bit smaller. There we go, not as far down. So this is time. All right, whereas the side of our thing right here, this is going to be temperature. Okay. So it says body temperature reaches a high. So the highest temperature is 120 degrees. All right, so I know that that's my max temp is 120 degrees. All right, it reaches its low at 104 degrees. So my lowest temperature is 104. All right, so I have my max and I have my min. So I need to find next for the temperature section, I need to find my middle, my midline. All right, to do that, I'm just going to find the average. So I'm going to add 120 plus 104 to give me 224, and then I'm going to divide by 2, and that's going to give me 112. All right, so my medium temperature, I'm just going to move this over. There we go. And stop doing that. There we go. Now I can fit everything. All right, and so my middle is 112. All right, so boop, boop, boop. That's my midline. And I can erase this because I don't need this anymore. Okay, so I have my y-axis set up, all right? And if you want to start writing down some of this information, because we have two pieces now of our equation, all right? So remember, in equations, you have so we have A, B, C, and D. All right, we now have the A and the D value. All right, so the D value is 112, right? That's my midline. So D is 112. All right, and then my A value, which is how far I am away from the midline, is going to be 8. Just double checking my math there. 120 minus 112 is 8, and then 104 plus 8 is 112. That is absolutely correct. Okay, so I have two pieces now of my equation. All right, so we're halfway there. All right, next I need to fill in the time section. All right, so it says blah, 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 blah. 35 minutes after they start timing. So my first thing that I have is 35 minutes after they start timing. So right here, I'm at the 35-minute mark. All right, and it says that's when it hits a high of 120. So I'm going to put my high of 120 at that 35-minute mark. Then it says 20 minutes later, it hits a low of 104. So I'm at 35 minutes. 24 minutes later, I'm going to hit a low. So I'm going to add 35 plus 24. So that's 59. So 59, I'm at my lowest point. All right. So I need to do one full cycle. So I need to figure out when is the next time I'm going to hit my highest point. Well, if it was 20 minutes, why did I do 24? That was stupid. 20 minutes later, let me just double check. 20 minutes after that, it reaches its next low. So 20 minutes, so 35 plus 20 is 55. Sorry. I don't know where 24 came from. I apologize. All right, so 55 minutes I'm at my low. So I know another 20 minutes later, I'm gonna be back at my high. All right, so I'm gonna add another 20. So 55 plus 20 is 75. So now I'm at my highest point again. All right, so that is one full cycle. All right, the only other things I need to find for my x-axis are going to be when it crosses the midline. So I need to figure out this point and this point because I want to know when is this going to happen, right? Every time you do your trig graphs, you should always have 5 points. That's going to be one full cycle. All right, getting your high, your middle, and your low points. All right, that's what we want. Now, the easiest way to do this is just to find what's in between 35 and 55. To do that, I'm just going to take an average. I'm going to add 35 and 55. So 35 plus 55, that gives you 90, and then divide by 2. That's how you find halfway, and that's 45. All right, you could have probably done that in your head. You probably didn't need to do that whole thing, but whatever technique you use, we're going to do it again to find the point between 55 and 75, and I'm just taking a guess here, but I think it's going to be 65. There we go. Okay, so here we go. We have our cosine looking graph, right? So this looks to me like a cosine graph. So we want to make sure that when we write our equation that we use cosine, but this is a sketch of our sinusoidal function. So some people have asked, and I don't know if Ms. Markert hit on this, but sinusoidal does not mean it's a sine graph. I know that it has the word sine in it, so you kind of think that it means it's a sine graph, but it doesn't. Sinusoidal just means it's any function that oscillates up and down. Oscillate, right, bouncing between two values. A sinus is like a sinus rhythm, right? So like if you ever watch like a doctor show, right, they talk about the sinus rhythm of the heart, right? It's the flow of the heart, the beating up and down, hitting the high and the low value. So that's what we mean by sinusoid or sinusoidal graph. It doesn't mean it's a sine graph. It just means it's a wave, right? There's highs and lows and it oscillates between the two. Okay, so our graph is done. We're done with number 9. Now we're going to pop over to number 10. We've finished 2 parts of it. Now we got to do the rest of it. So we need to fill in our B value and our C value. I'm going to do the C value first because that I can easily just get from the graph. Your C value is your phase shift. We have moved to the right 35 minutes. So C is 35. All right, and then my B value is my frequency, which I don't have frequency, but I can figure out the period, which is going to help me find the frequency. So period is how long it takes to do one full rotation. So to find this, I'm just going to subtract 75 minus 35, right? And it took 40 minutes, right, to go from 35 to 75. So I have a period of 40. Okay, so to find my B value, it's going to be, and let's see, does it specify if we're doing degrees or radians here? It doesn't specify, so it's dealer's choice. Since I'm going to be problem number 12, looks like it wants me to work backwards and calculate things, so I'm going to do this in degrees, just so my numbers are a little bit more friendly. So I'm going to do 360, so B is going to be 360. Divided by my period, which is 40. So 360 divided by 40 is 9. So my B value is 9 degrees. Okay, now I can go ahead and I can make my equation. So I have y equals 8 cosine 9 degrees x minus 35 plus 112. All right, so there's my equation. Next, I'm going to move to question number 11, which says, what was the creature's body temperature when they first started timing? Okay, so when they first started timing, that would mean that t equals 0. right? Time equals 0, or in this case, since I used x's and y's in my equation, that means x is 0 because time is our x-axis. So that's what I'm going to do. So I'm going to plug in 0 for x. I'm going to figure out what y is because y is temperature. All right, so I have y equals 8 cosine of 9 degrees. 0 minus 35 plus 112. All right, and then I'm going to just throw that into my calculator. Remember, since I chose to do this in degrees, because I chose 360 instead of 2 pi to find my b value, I need to make sure that my calculator is in degree mode. So just hit mode. The third line down is radian and degree. Make sure degree is highlighted. And then I can just type everything in as exactly as I see it. So 8 cosine 9, 0 minus 35. Remember to use your parentheses, plus 112. All right, and I got y equals 117.65, so I'm going to say 0.7. It doesn't say what I'm supposed to round to, so it's dealer's choice. So we'll say 117.7 degrees Fahrenheit. All right, last part for this one is problem number 12. So let me move my face real quick. There we go. All right, it says find the first 3 times after they started timing at which the temperature was 114 degrees Fahrenheit. All right, so this is giving me a y value. All right, so it's giving me a y value and it wants me to find the x value that goes with that y value. All right, so I have to do a little bit of algebra. I got to do some working backwards, but that's okay. I can do that. So I'm going to plug in 114 for y. 114 equals 8 cosine of 9 degrees, x minus 35 plus 112. All right, so subtracting 112. All right, that's going to give me 2 equals 8 cosine 9 degrees, x minus 35. Close, close. All right, divide both sides by 8. All right, that is 1/4 equals cosine 9 degrees, x minus 35. All right, now, this is something we're going to talk a lot more about starting next week, but we need to move the cosine to the other side. We need to get rid of it. So what we're going to do is use the inverse cosine function of our calculator, which is the cosine to the -1. And I'm going to do that on both sides because I need to get rid of that cosine. All right, so I have inverse cosine. All right. Then that leaves me with so I go to my calculator, I hit second cosine, I type in 1/4 because that's what I have over there, hit enter, and that's going to give me 75.5. Because I want to deal with whole numbers, I'm just going to round that to 76. All right, so I have 76, and that's degrees. Remember, we are using degrees in our calculator, so that is a degree, equals 9 degrees, and then x minus 35. Okay, oops, let me scroll sideways for you. There we go. All right, now I'm just going to continue solving. So I'm going to divide by 9. All right, so divided by 9. All right, that's going to give me 8.4. Probably should just leave the decimal in there. We'll just say 8.4. Let's see. Yeah, we'll just say 8.4. That's fine. X minus 35. Okay, and then we're going to add 35 to both sides, plus 35. That gives us 43 Okay, so if we go back over to our graph, all right, I'm just gonna zoom out a little bit. There we go. Okay, so if we go back over to our graph, this is telling us that at 43.4 minutes, we are going to be at a degree of 114. So I'm going to kind of put that over here on my graph. Actually, first, I'm going to go yell at my dog to stop barking. Hold on. Okay, sorry, I had to pause, go yell at my dog. Now I'm back. Even though it was only like, it wasn't any time for you, it was time for me. All right, so back to our problem. So 43.4 is how long it's gonna take us to hit a temperature of 114. So we were heading over to the graph, and I'm just gonna mark this. There we go. So 43.4. So 43.4, and that's gonna give us 114 degrees. All right, so there we are. Kind of marked it on our picture. Now, the next time we're gonna hit 114 degrees would be right here, right? Because it's gonna hit 114 again, right about there. And how we're gonna find this is we're gonna use the rule that we've talked about. On any sinusoidal, cosine, sine, whatever kind of graph, all of the points are equal distance apart from each other. So what I'm going to do is draw this invisible line going through like that middle point of my graph. Now, however far away 114 is from that middle line, that's how far away the other 114 is going to be from that middle line. All right, so I'm going to take 55, which is the middle, and I'm going to subtract 43.4. All right, that tells me that this point right here, right, is 11.6 away from the middle. Well, this 114 has to also be 11.6 away from the middle. So I'm just going to take 55 and I'm going to add 11.6. All right, that's going to give me 66.6. So that is the next time that I hit 114 degrees. All right, so x equals 43.4. X also equals, what did we say it was? Oh, down here, 66.6. All right, and then to find the third one, because it says it wants you to find 3 times, we're just going to use the period of the function. So this 43.4, all right, if I add a period to it, it's going to pop up again. So I'm going to take the 43.4 and I'm going to add my period, which is 40. Sorry, I should have just looked up there, which is 40. And that's going to give us 83.4. So it's going to keep hitting, right, that 114 at all of these different places. Right? And we could keep going too, right? So now that we have 66.6 as our next point that we're going to hit on our graph, we could add, to find another one, we could just add 40 to that 66.6, and that's going to give us the next time that that point happens on our graph. So remember, and then it just keeps repeating and repeating forever and always because it's a cosine graph. All right, so let's jump into the second problem on the back. All right, so scrolling down. Okay, all right, so this one says assume, and I'm gonna just move my little picture here. All right, so it says assume you are aboard a research submarine doing submerged training exercises in the Pacific Ocean. At time t equals 0, you start porpoising. Okay, which means going deeper and shallower. All right, at time t equals 4, you're at your deepest. Y equals negative 1100 meters. At time t equals 9 minutes, you reach your shallowest. Y equals negative 200 meters. Assume that y varies sinusoidally with time. All right, so first, just like the last one, we're going to go ahead and we're going to sketch a graph. All right, and then we're going to label it. All right, so setting up our y-axis, it tells us that our deepest is negative 1100, our shallowest is negative 200. To get the negative 650, you do an average. So you add 200, 1100 divided by 2 gives you 650. All right, next we're going to set up our x-axis. All right, so it says you're at your deepest, so a negative 1100 after 4. And then 9, you're at your shallowest, which is 200. The difference between 9 and 4 is 5. So I know another 5 is going to give me my shallowest again. Right? That means that my period is 10. All right, because that's how long it takes me to do one full rotation. Last thing I need to do is figure out the points in between the 4 and 9 and the 9 and 14. So to do that, we're going to take an average. And I believe this is going to give us a decimal, right? 9 plus 4 divided by 2. So 6.5. So this is 6.5 and then 11.5. And that's when we're going to touch our midline. All right, so here we have our function. All right, so next up, we are going to make our equation. So I'm going to start by finding all of my different values, A, B, C, and D. All right, my amplitude for this problem is going to be 1100 minus 650, so 450. All right, my B value, so my period is 10, and I'm gonna go ahead and do this in degrees again, just because I am gonna need to find other values here, so it's easier to work with degrees because they play nicer. So I'm gonna use degrees again. So that's 360 divided by my period, so that's gonna give me 36 degrees for my B value. All right, C is my phase shift, and I am starting at 4, so I have a phase shift of 4, and then my D value is minus 650. All right, so now I can go ahead and make my equation. So y equals 450, and it's negative 450 because we are upside down, right? So if you look at a graph, this is an upside down cosine. So we are at negative 450. Cosine of 36 degrees, x minus 4, and then minus 650. All right, so there's our equation. Next up, it says your submarine can't communicate with ships on the surface when it is deeper than y equals negative 300. At time t equals 0, could your submarine communicate? All right, so it's saying, it's giving us time equals 0, so we want to plug in a 0 for our time. That's an x value, right? So x value. And see if we are at a depth that's greater than negative 300, right? So that's what we're going to do. So y equals negative 450 cosine 36 degrees, 0 minus 4 minus 650, and then plug it in. All right, and I ended up with y equals negative 285.9, all right, which is less than negative 300, so the answer here is yes. Awesome. All right. Next it says, between what two non-negative times is your submarine first unable to communicate? All right. So it says it can't communicate with anything deeper than negative 300. So between what two non-negative times? All right. So I'm going to, I guess we'll say y, when is y going to equal negative 301? Right? So that would be like the next, right, meter deeper or whatever. I guess we would have to do, we could do this less than or equal to. We could say we want y to be less than negative 300, and we could solve it as an inequality, but I'm definitely okay if you just want to do y equals negative 301, which I think actually is what I'm going to do. It's less accurate, but I'm fine with it. Right, so I'm going to know when is it going to hit 301. Okay. Okay, so we're just going to plug this in for y, and we're going to work backwards and solve for x. Okay, now divide. So negative 0.776. All right, inverse cosine to move it to the other side. So inverse cosine. All right, that's going to give me 140.86 degrees. All right, divide by 36 degrees. All right, and 3.9, and add 4. So 7.9. All right, so, whoops, let me scroll. There we go. All right, so I have x equals 7.9. All right, so now I'm going to go back to my graph, and I'm going to do the same thing I did before. So I'm going to plot all of my stuff. So I have 7.9. So here's 9, here's 6.5. Say here is 7.9. And this is at negative, so we got negative 301, right? Something like that. Okay, so I want to find the next time it's going to hit that value. So remember, it's equal distance over here. All right, so I'm just going to subtract 9 minus 7.9. That gives me 1.1. So I just need to take 9 and add 1.1 to find my other point. Because remember, this is kind of like our middle line, right? So plus 9, and that's 10.1. So 10.1, that's when it's going to hit 301 again. And 10.1. Here we go. All right, so those are 2 times where our submarine is not going to be able to communicate. So between what 2 non-negative times is your submarine first unable to communicate? So between 7.9 and 10.1. So this is when we lose signal-ish, right? We know we did a little rounding, but that's okay. All right, that is it for today. Hopefully that was helpful and helped you guys who were having a difficult time with the back of the homework. All right, bye.